those questions? Because you're gonna see this material again.
The 5,000 was tag page into SLC 500 is rack based memory.
Yeah.
Fixed.
Yeah, that's what you want, yeah. That's exactly what you want. So it's fixed versus flexible, right? Fixed versus flexible. And the MicroLogix, they're the very same thing as the 500. They have all the same memory structure, the same basic operating system, all that stuff, firmware, with a little less capability. What exactly does that mean? Who did the homework? I mean, a lot of people did, some people didn't, and that's fine. But what'd you get out of the book? What'd you get? Or did you just blast through the questions and
I blasted
start
through the
finding the
questions.
answers?
No answers.
It's basically
Well,
just
honestly,
the way they
you know.
communicate, right? It's tags, you follow the tag all the way through, whether you're in a program or a cycle.
I tell you what,
Kind of like your
company,
application.
Yeah. Yep. Yep, that's right. I gotta hand back these tests too, don't I?
Does everybody think?
No. But we are gonna review these, but not, we're gonna do review the homework first, and then whoever hesitates can step out. Fixed versus flexible. What's the difference?
Fixed, you can't add anything to it. It's flexible, you can add or remove I/O modules as you wish.
Yeah, yeah, that's kind of, yeah, different between and like, yeah. So, here's the thing. The MicroLogix and the Slick 500 PLCs, all the legacy type PLCs, the old PLC 5, everything goes back from ControlLogix, CompactLogix back, was all, the memory organization was fixed. What that means is, you know how when you look in the project tree, you have this, all the data files, S2, static file, B3, the binary file, T4, timer, counter, C5. It's all based on 1, 2, 3, 4, 5, and that's the way it has to be addressed, right? We take, let's if we address a binary address, it has to be B3 0:0/0, right? And that is hard coded in the PLC. That's part of the firmware of the PLC. So we have to use that addressing for the PLC to even know what it is. I know some of you have, you've dropped in an XIC instruction, and I've seen this before, and you might just put a word on it or a symbol like binary. But then it errors out on you, don't it? Because it says, oh, this is not an address. So you have to use those addresses that are hard-coded in the memory of the PLC. Now, the CompactLogix, on the other hand, it's flexible, and the reason they call it flexible is because we make tags, names for addresses. That's all it is. We don't have to use an address, a physical address. We use a name. Instead of B300, we can call it internal relay. Instead of T4:0, we call it Jimmy's timer, or whoever, Garrison's timer, my timer, your timer. You can't call it whatever you want, and that becomes the address in the Logix 5000 system. And this, it'll all come clear once we get into it. There's not a lot to it. I do. This the first couple of weeks, I know we blasted through a lot of material, and I apologize for that. This thing will level out, so just hang in there. But we had to get through analog, and that was that's something we didn't get a chance to cover last semester. And it was something that's very important because this is the basics, right? The analog. We're also gonna be getting into analog in the CompactLogix, but you have to learn that stuff before we jump into the CompactLogix analog stuff. So I hope everybody's got a good grasp on analog in the short 2 weeks that we covered that stuff. And hopefully you will once we get into CompactLogix. But yeah, just hang tight and hang in there. This stuff, it will level off. But here's another thing. I know a few of you, some of you are like a few classes, you can probably count them on one hand, away from getting out of this whole program, right? 2 classes, 3 classes, yeah. Some of you are real close, and it's real easy to just say, I give up. You know, I've had enough. Enough already. Don't do it. Don't do it. You gotta keep on keeping on, right? Keep plugging away. Keep your head in the game at all times. You gotta do it. Keep your head in the game, keep your mind on the game. Because I've seen it, and that's the only reason I brought it up. I've seen it in some people where they're just like, I don't know. And I get what you're talking about, believe me, I understand. I've been there, I've done it. Believe me, I've done it 3 times. Luckily, fortunately, the first time I did it, I was right out of high school. Yeah, I worked in summer jobs, okay, whatever. Second time I did it, I was working a full-time job. Right? Third time I did it, I was working a full-time job, had kids. Wife, married, tied down. It's hard, believe me. Hard, but you got to keep plugging away. You got to, you can't just throw in the towel and say, oh, I'm done. You know, that's not what it's all about. What it's all about. What do we have? But yeah, this thing will level off, so just hang in there. What does a project contain?
Tasks, programs, and routines.
Yes, thank you. Somebody got it. And here's another thing. You might want to take notes on this stuff unless you already know it, because you're going to see this again. And like, I talk about this all the time, I apologize, but I've got to say it again. Today's Thursday, so you're not gonna hear anything about this until Friday, Saturday, Sunday, Monday. You got 5 days, right? There's a lot that goes by in 5 days, and then you forget about it. So please come in, take notes, and review your notes when you're outside the classroom. That's what's gonna get you there. That way you're not having to do all this last minute rush thing to try to pass the test. Because if you do it a little at a time, you got it. Just do it a little, it's not that hard, but you gotta do it a little, you gotta take it in small pieces too, right? You can't do it all at once. Okay, none of that. Yes, task, programs, and routines. Does anybody recall scheduling, the order of scheduling?
Tasks are first.
Yes. Tasks are the first level of scheduling. That's right. Program, second level. Routines, third level. And here's the thing. There's a lot of buzzwords in this stuff, right? A lot of terminology, and that's all it is. It's just terminology and buzzwords. Does it mean something? Yeah, it does. But don't get caught up in the buzzwords and the terminology. Because it's not that hard once we get into it. Explain the function of task in the project. What are tasks made up of?
Their scheduled programs.
Yeah, scheduled program, yeah, a group of scheduled programs. That's right. The three main types of tasks.
Continuous, periodic, and periodic event.
Yeah, continuous, periodic, and event. And here's kind of an analogy. The project is basically your program. But it's a way of organizing things. You have the programs, the tasks, and routines. It's just like the MicroLogix. You have a project, right? It has one program. That program contains ladder 2, ladder 3, ladder 4, ladder 5, all the way up to ladder 255. That's the program. In MicroLogix, in the Slick 500 world, you can only have one program. Whereas CompactLogix, you have, I think it's 250, I don't know what it is. It might be limited to the memory and the PLC. I don't know. The book probably tells you, but does everybody understand that? There's one program in the MicroLogix, and you can have numerous programs in the CompactLogix. Yes? Okay, good. So we have the project, right? And it's made up of tasks, programs, and routines. Within the task, there's three different types of tasks. There's, what are they? Continuous?
Continuous, periodic, and event.
Periodic, and event. And how that works is, let's say that Luis hired a contractor to build a house. This is a project, right? This is a big project, and there's different tasks, different types of tasks within this project, right? So the continuous task would be, let's build this house, build this house, build this house, build this house, right? Periodic task would be, okay, every 4 hours we're gonna take a break. Every 4 hours we're gonna take a break. In the PLC world, we're gonna say, let's run this machine, run this machine, run this machine, run this machine. A periodic task would say, every 30 seconds or whatever it is, let's grab data and store this data away. Let's do some data collection. Let's do some data collection. Data collection. And then event driven, what does that mean?
Something happens.
Yeah, something happens, right? It's an emergency. Luis's house is being built and the dumb carpenters run out of lumber. Oh, we gotta go get lumber. The project shuts down, right, for however long to go get the lumber. So in the PLC world, an event-driven task might be as simple as somebody hit an E-stop. So we run this routine, we run this task to do something with all this fault messaging. Maybe we send, whatever. Go call maintenance, flash lights all over the place, whatever. So event-driven task, or a proc switch gets short. A proc switch goes bad. And the logic that you have built in there recognizes that the proc switch goes bad. So we put an alarm on the HMI to say, hey, operator, call maintenance. See, so this event thing, it's running a separate piece because something happened. It's running maybe a separate routine because something happened. What do we got? Explain the function of programs within the project. What's the function of the program?
Second level schedule.
What are programs made up of? What's in the program?
Routines.
Yes, routines, yeah. Yep, that second level of schedule, yes. The book doesn't do, I don't think, a very good job of explaining this stuff, but that's the main points. Explain the function of routines within the project.
They contain the code that says, do this.
Yes, they're the workhorse, right? They're the workhorse. Those are the ones that are, in the routines have all your ladder logic built into it. That's where you put all your ladder logic. That's what's actually doing the work. What's four types of programming languages? Ladder diagram.
Sequential function chart, structured text, function block with ladder logic.
Yes. Yeah. That's a given, I think. And here's the reason behind those four types. Back when all this PLC stuff got started, back in the 70s or whatever, maybe 60, I don't know, I can't remember.
Was sequential function the same thing as graph set?
It is, yep. Good point, Scott, yep. Yes, it is. So back when all the PLC world stuff got started, everybody was kind of doing their own thing with it, right? So this guy couldn't understand this person's stuff, this person's stuff, and so on, and it got to be a big